All right, so hello students who aren't here now because you had to go take a test. Pause you should have the notes from me that were delivered, and pause the tape and copy these ones down. They're the first one. So I want you to have an example. Here you can see steps 1 and 2, steps 3, step 4 and 5. All the steps for finding the 6 trig ratios. Okay, so pause the tape and copy it. There we go. Everyone in this class good? Okay. All right, so hopefully you did that because I'm moving on to the next problem. They can pause it. All right, so I started this one with my, I believe we started this one yesterday. This is also where 6th period got, so I left it there. I figured we were all in the same location. So you can just kind of copy it down with me. I'll go through the steps. So our first thing is we drew the angle. That was the 120-degree angle. And then we find our reference angle. And so we drop a line perpendicular to the x-axis. So here we're just going to go right straight down to the x-axis. And then to find our reference angle, we're in the second quadrant, so we subtract our principal angle from 180. So 180 minus 120 is 60 degrees. All right, so here we have already done step 1 and 2. And of course, finding the reference angle here is also part of step 2. Step 3, we've already labeled. I don't know if we got to this in this class, but this is the 30, 60, 90. So for the 30, 60, 90, the short leg, it's the one opposite the 30, so in other words, not opposite the 60, is 1. The long leg is opposite the 60-degree angle, so square root of 3, and the hypotenuse is 2. So all of our special angles will involve either the 45, 45, 90, and its sides are 1, 1, square root of 2, and the 30, 60, 90, and its sides are 1, square root of 3, and 2. So someone in my 6th period class asked why 1, 1, and square root of 2. How do you know it's 1? Maybe it's 5. And well, actually, we could use 1, and we could use 5, and we could use 100. It really wouldn't make a difference because it would still reduce. Because then you'd have 100 over 100 square roots of 2, and it would just reduce anyway. So that's why we just use the simplest number, so we don't have to bother reducing. All right, so step 3, we already have our triangle up there. Step 4 is to set up our trig ratios for a reference angle. So we already have sine up here. So sine is the opposite over the hypotenuse. That's square root of 3 over 2. Cosine is the adjacent over the hypotenuse. So notice that we're negative here because x is negative in the second quadrant and y is positive. So our cosine ratio is -1/2. And then our tangent ratio is the opposite over the adjacent. So square root of 3 divided by -1, which is just going to reduce to negative square roots of 3. Any questions so far on these ones? And then we're gonna do the other 3. All right. So let's do cosecant 60 degrees. And this is going to be interesting. How long will it take for I actually get somebody who's in here? And 6. No. Just picking 24. Monique is the lucky one. The cosecant ratio. And then if we rationalize it, what would that be?
What do you do to rationalize it?
So when we rationalize it, we multiply by whatever radical's in the denominator. So we're going to multiply by the square root of 3. Oops. Yeah. You are correct. I accidentally started to write the wrong thing. And I couldn't stop myself. Move it back. So that would be 2 square roots of 3 over 3. Yep. How about our secant ratio? So secant 60. No 19. 21. Gabe?
It would be 2 -1.
Yep. Which is just -2. And then finally, our cotangent ratio. No 14. 5, Abby. Mm-hmm.
Yeah, square root of 3 over -1. Right? No?
Not the square root of 3 over -1.
2 over -1?
No.
What?
So
Isn't it the opposite?
cotangent is adjacent over
X
opposite.
over y.
Yes. You didn't give me an x over y.
Oh, it's negative 1 over square root of 3.
There you go.
It's the opposite.
Oh,
We
this
said-
x. Okay, I get it, yeah.
because we said-
And so then we have to rationalize it. So when we rationalize it, that would just be,
-1 square root of 3.
yep, negative square root of 3 over 3. And there we go. We have all of our trig ratios, so it's just that easy. Those are all the steps. Right. Let's continue on. Nope, same angle. All right, so the -30 degree angle, which quadrant am I going to be in? 23, Monique? Megan? What quadrant will I be in for the -30 degree angle? The fourth quadrant. All right, so our angle is going to be over here. So that's our angle. It's going this direction. All right, -30 that direction. And we can just drop the perpendicular. There we go. So we have a negative angle. Let's find our coterminal angle. That would be positive, and then we'll find our reference angle. So coterminal to -30. So what do I do to find the angle that's coterminal to the -30 degree angle? Jared.
Would you do
360 plus, -30 plus 360. So we have -30 plus 360 would give us 330. So here is our positive angle, 330. And then our reference angle, we're in the fourth quadrant. So if my principal angle equals 330 degrees, what do I do to find my reference angle? Scott? So if we're in the fourth quadrant, to get the reference angle,
330 minus -30? Or
no,
plus?
no. Remember we had the three rules. We had one rule for the first quadrant, one rule for the second, one rule for the, one rule for the second, third, and the fourth. So we're in the fourth quadrant.
Oh, 360 minus P.
So we take 360 minus 330, and probably the whole time you figured out that our reference angle is positive 30 degrees,
P is
our principal angle. Yeah. So 30 degrees. All right, so now we need to label our triangle. So now we've got step one, we've got step two. Now we need step three is the labeling of the triangle. All right, so opposite, and notice I didn't necessarily draw this to scale. You can kind of see that. That's okay. I'm not required to draw it to scale. All right, so opposite the 30-degree angle should be what side? Owen? 1. How about this adjacent side? What should that leg be? Yep, square root of 3. And then how about the hypotenuse? 2. Yep, there we go. Right, so all you have to do is remember your special right triangles. You gotta remember those two special right triangles. So now we have our triangle all labeled up, and so now we can find our trig ratios. Right? So now we're all the way up to sides 4 and 5. I like to do side 5, step 5 here while I'm doing step 4, and that is I like to make sure that I have the right signs on the values. So are any of those values, should any of them be negative?
The 1.
The 1, yeah. The 1 should be negative, right? Because our x is positive, but our y is negative. So if we label the 1 negative right now, then we don't have to worry about remembering to go back and check. But it's a good idea anyway. So when we get to the end, we'll go back and we'll check and make sure that we have the right number negative. I didn't do that on the last one. We can go back and check real quickly. So on the last one, there should be 4 that are negative and only 2 positive. All right, so which 2 should be positive in the second quadrant?
-3 and 2.
Which of our trig functions?
The cosine and the cosecant.
Should be, which one should be positive? Cosecant is one of them, but not cosine. Sine. Remember, all first students. So it's sine, cosine. Excuse me, sine and cosecant, and then take. So tangent, cotangent, and in the fourth quadrant, calculus. It's cosine and secant. So let's double check. So sine is positive, cosecant is positive, and all the others are negative. So we know we got those right. So I like to put the negative on the value on the triangle, and then I like to just go back and check that the right ones are positive and the right ones are negative, just to make sure. All right, so we're on this one, and so let's find our sine ratio. So sine, oops, we're looking for sine 60. We're looking for sine 30. All right. And back to the beginning. Monique? Yep. And then we'll write down cosine 30. So it's cosine 30, 21. Is that Gabe?
So cosine 30 would be the square root of 3 over 2.
Yep. Square root of 3 over 2, the adjacent over the hypotenuse. And then tangent 30. What would that one be? Abby?
-1 over 2.
No.
Just square root of 3.
Yep. Opposite over adjacent, and then let's rationalize that.
-1 square root of 3 over 2.
Yep. Oops, I'm missing my negative. Okay, squeeze that in there, I guess.
For
Yeah.
the other problem, there's a 1 somewhere in there. I don't know.
What's that?
Okay, so for the other problem, is there supposed to be a 1 right there?
Yes. And that would be a -1. All right, so now let's do those are the principal ones. Let's do the other ones. Cosecant 30. 23. Megan? Yep. And we can just write that as, simplify that to -2. And secant 30. Jared? And then if we rationalize it, yep. And then last but not least, cotangent, Scott.
-3 over negative, or 3, square root of 3 over -1.
Yep. And it doesn't matter where the negative is, and that would just be negative square root of 3. Yep. And then we're all done. Okay, so those are all the steps for finding evaluating for an angle. That's what the x and y, the signs of the x and y are.
Okay, so the y is positive and
The x is positive and the y is negative. Yeah. And let's double check. So who should be positive in the fourth quadrant? Which of our trig ratios?
cosine and secant.
Yep, cosine and secant. And they're positive, positive, and everyone else should be negative. And we can see all four other ones have negatives. So our signs are good. So we got 3 done, 3 to go. Now we're going to work on radians. All right, so we have the 5 pi thirds, right? So when you're, and I can give you a, a little guide, a little unit circle. It's got the radian values on it, so you can kind of see. But kind of ask yourself, is that more or less than 1? So is 5 pi thirds more or less than pi? That's more, right? That's more, right? Because 3 pi thirds would be 1 pi. So we got to be more. We got to be at least somewhere down here. So am I going to be in the third quadrant or the fourth quadrant? Should be in the third, right? Well, let's see. So let's see if it's in the third. All right. So this would be 3 pi. Oh, good. You guys are back.
There are 100 questions. They're like the simplest questions. Like, who was the first president of the United States? George Washington.
So we tape the lesson. When everyone gets here, I'll stop the tape. So that way you can just go back and you'll watch the tape for the first 16 minutes. All right, so this would give us 3 pi thirds. If I have one more third, I'm going to be a little bit further, but I've got 2 more thirds. So it's 2 thirds. This here would be 3 pi halves. So is 5 thirds bigger or smaller than 3 halves? It's bigger. It's bigger. So we're going to be in the fourth quadrant. All right, so back in the fourth quadrant again. So here is our angle. And so this here is 5 pi thirds. We need to find our reference angle. All right, so to find our reference angle for the fourth quadrant. Oh, yeah. Yep, there you guys go. All right, so to find our reference angle for the fourth quadrant, what do we do when we're in radians? Matt, why don't you can just dump that stuff out of your way. You can just throw it in that crate right there, so you have some space. Thanks. All right, so maybe we'll let our people that just got here get acclimated. I'll call on the last card. No, we'll add the new people in. So Owen, how do I find my reference angle if I'm in the fourth quadrant? Yep. So for the fourth quadrant, our reference angle is going to be 2 pi minus our principal angle, minus 5 pi thirds. So 2 pi is how many thirds? 6. So we have 6 pi thirds minus 5 pi thirds, and that means we are 1 pi third. Yep. So our reference angle right here is pi thirds, and we want to set that up. All right. So now, first of all, is this going to be a 30, 60, 90, or is this going to be a 45, 45, 90? It's going to be a 30, 60, 90. So, and if you look back, I have a little hint on the very front of the paper. So which side should go opposite pi thirds? Numbers, because it's our special triangle. What's that? Well, that'll always be that'll opposite, right? Because if I'm opposite, it's my opposite side. But what number goes the opposite what number goes opposite pi thirds? No. What's that? No, that's not one of our sides from our special right triangles. What side goes opposite pi thirds? Square root of 3, yes. Pi thirds is the same as 60 degrees, square root of 3. What would be our other side there, our adjacent side?
Ms. Pacheco,
Yeah.
the last one is wrong if that's the square root of 3, or if that's the square root of 3.
Yeah, the other one's negative 1. It should
Well, I didn't draw it to scale.
No, the last triangle, we made the opposite side -1.
Did we?
be- Yeah.
You guys are just noticing?
That's because we have a third.
We're not noticing this because
That's a 30-degree angle. That's correct. Yeah. So 30 degrees is correct for square root of 1. I have a tendency to make all of my triangles look identical. I'm not so good at making them look correct size-wide. What's that?
I was making mine like exact triangles.
That's okay. So long as you understand that they're just models, and you maybe not like I have a tendency not to make that go in the right spot. Can you pass that back? Make sure you get notes. We're on side 2. I've taped side 1 for you. As soon as I get through this problem, I'm going to shut the tape off, I think. Everybody get one? Oh, that's extra. So I was going to sit back there. All right. So then, but thanks for having us check though, Jared. But no, that one's correct because that's a 60-degree angle. Pi thirds the same as 60. Yep, this pi thirds. So then, what's my adjacent side right here? I thought I heard it, just so softly. Our adjacent side is?
Is that negative 1?
Nope, it'll just be 1, but
Or 1.
yeah, because that x is going to be positive, right? So x will be positive, y will be negative. This is going to be the negative one. And then what's my hypotenuse? 2. There we go. So now make sure you have those values from the special right triangles committed to memory. And that one looks more drawn correctly than my other one where I had the larger side opposite a 30-degree angle. But technically it was the smaller side. I just didn't draw it very well to scale. Yeah.
So what is like the 3 pi over 2 next to the positive and negative? What is
Oh, so this is just helping us remember the sizes of going around here. So this is 0. This would be pi halves. This would be pi. And this is 3 pi halves. So trying to figure out where 5 pi thirds should go, which quadrant should it go in. And so students said it was larger, that 5 thirds is larger than 3 halves. And they're correct. 5 thirds would be 1.67. 3 halves is 1.5.
What's that random 3 pi over 3 doing? What's
Oh, well, I could put just pi there if you'd like.
Well, I didn't know what it went to.
So I'm just labeling the coordinate plane there,
Oh, okay.
so that you know how many radians it is going around.
Okay.
All right, so now we're already ready up to step 4 now because we've got our triangle there, and so now we want to find our trig ratios. All right, so we found our principal angles, 5 pi thirds. We graphed it. We found our reference angle by subtracting 5 pi thirds from 2 pi. So pi thirds is our reference angle. Pi thirds is the same as 60 degrees. It's a 30, 60, 90. So our short side, and it actually is drawn to scale and looks short, is 1. Opposite pi thirds will always be square root of 3, and the hypotenuse is 2. So maybe your triangle's not drawn to scale. Just make sure that square root of 3 is opposite pi thirds, even if your triangle is not very well drawn to scale. All right, so now let's find our sine ratio for pi thirds. And I can bring more people in now. Yes. You gotta get all these people that haven't answered any questions. These guys have answered like a whole bunch of questions. All right, sorry, Owen. 17 was the first one I got. So what's the sine ratio for pi thirds?
it's negative square root of 3.
Yep. So if we put the negative where on the y value there, we don't have to remember it later on. So that's why I always put the right signs on the values to begin with. All right, so now let's find our cosine ratio for pi thirds. And 9, 11. No, 13.
Oh, that's only 12.
We have to have somebody here. 19, Michael, cosine ratio.
I'm gonna be 1 over 2.
Yep. And then our tangent ratio for pi thirds. All right, so what would that be, Matt?
Would be
It's always the sides of our triangle, right? And tangent is opposite over adjacent.
So then it'd be 2 over square root
2 is the hypotenuse. It's opposite our right angle there.
1 over square root
1 is the adjacent side.
Okay. So wait, exactly.
square root of 3 over 1.
There you go, except it's negative. So negative square root of 3 over 1, which is just negative square roots of 3. All right, the reciprocal function for sine would be cosecant. So cosecant pi thirds, what would that be? 12.
That's,
Yep.
so would it be cosecant is,
Cosecant is hypotenuse over the adjacent.
oh, so 2 over 1, yeah, so,
Yes.
opposite of cosine.
Sorry, what did I just say? I'm sorry. Cosecant is the hypotenuse over the opposite. I'm sorry.
It's 2 over square root of 3.
Yeah. And it'd be negative. So 2 over square root of 3, but that would be negative.
Oh, that's negative?
Yeah. Because our y is negative. So now we want to rationalize this. So then if we rationalize this, what would this be rationalized? Class? What would that be rationalized? Yep, and it's negative. So 2 square roots of 3 over 3. That negative, I think, is getting lost. And then finally, cotangent. What's our cotangent ratio?
Did you forget secant? Cosecant?
Oh, we did. We forgot secant. Sorry, it was all crammed in there. We forgot secant. I didn't even notice him. I'll move this one over here so I've got a little bit more space. Move these guys up a little bit.
No, that doesn't go to negative 2. That goes to the,
That goes with cosecant, or with sine, because this is all part of cosecant.
but isn't it the negative square root of 3?
Yeah, it's not negative 2, it's
Yeah.
negative square.
Doesn't matter where it
It
is.
doesn't matter.
Yeah, there you go. I'll put it back in there. All right, so now secant. So secant pi thirds. What would that one be? 10, Brian.
That would be 2 over 1.
Which is just 2. All right, and then cotangent pi thirds. What would that ratio be? 18, Bryce.
Wait, what are you asking? Sorry.
Cotangent, what would the cotangent ratio be?
Okay, so it would be the.
It's tangent flipped.
So cotangent is adjacent over opposite.
Oh, you're asking. Okay. And
Yeah.
Where's the degree? Sorry, I just don't remember where's the degree.
For pi thirds. So for our reference
So
triangle.
right there. So.
Uh-huh.
And you're asking for cotangent.
Yep.
Okay. So. Cotangent. Opposite. So the negative square root of 3. Or is that negative? Okay.
It is negative, but cotangent is adjacent over opposite.
It's the opposite of tangent.
Oh, so 1 over the negative. Sorry.
There you go. 1 over negative square root of 3. And so now we want to rationalize it. What would that be rationalized?
It would just be negative square root of 3 over 3.
Negative square root of 3 over 3. Yep. And then we're all done.
Oh, shoot.
Right.
I didn't realize you read it and put sync in.
Yeah. All right, so when we're graphing these, I'll go through the steps. I'm gonna do another problem. All right, so we graph our reference angle, our principal angle, right? And then our reference angle is always the short way to the x-axis. All right, so we have our 3 ways of finding it. If it's in the second quadrant, then it's just 180 minus our principal. If it's or pi minus our principal. If we're in the third quadrant, it's our principal minus 180 or our principal minus pi. And if we're the fourth quadrant, it's 2 pi minus our principal angle or 360 minus our principal angle. Okay? And then all of our angles are going to be from the special right triangles. Our special right triangle angles are the 45, 45, 90 and the 30, 60, 90. And then in radians, that's going to be pi fourths, pi halves, and then In the 30, 60, 90, it's pi thirds, pi 6, and pi halves. But we're only going to ever use the acute angle. So the 90-degree angle doesn't really matter. This is always going to be acute. It's always going to be the one that's against the origin, because that's our reference angle. Okay? It's always the one that's right, it has the vertex on the origin there. All right? I'm going to pause this tape. I'm going to end this tape.